It is best represented by its components. So its components along three orthogonal or perpendicular directions. So we can define a coordinate system. I had told you about the right-handed coordinate system earlier. So what is right-handed coordinate system? If you take x-axis to y-axis, so you are doing a counterclockwise rotation. You want to move x-axis to y-axis. Now it's a counterclockwise rotation. If you have a right hand screw, it will come outward. If z-axis is in direction of translation or movement of a right-handed screw, then it is a right-handed system. Now, in a right-handed system, I cross j is equal to k. You have got unit vectors along these directions, x, y, z directions. How to define a unit vector? How do you find a unit vector? Now we have got three coordinates here, x, y, z. Three coordinates are
So unit vector is a vector with magnitude 1 and having direction in a particular plane, like on towards a x-axis to an x direction, and only on y direction and only on z direction.
so what you have to do is just change one coordinate, keep others as zero. So your x-axis is only increasing, y and z are not increasing. So you will get your unit vector along x direction. So you have to have unit vector basically by definition has what magnitude 1 or unity. Only thing is you have to change only that x coordinate. If you want unit vector along y direction, you have to change only y coordinate, x and z will not change. This way you can get unit vectors along the three directions. Okay. Okay. Now also one more thing. Here we are dealing with a Euclidean space. So Euclidean space means shortest distance between 2 points is given by a straight line joining them. So if you have 2 points x1, x2, x3, and y1, y2, y3. This is the shortest distance between them will be so then it is a Euclidean space, or it is also called a flat space. So it is different from a curved space. For example, if you are told that you are restricted to stay on the surface of a sphere, then shortest distance joining those 2 points in that curved space will not be a straight line. It will be arc of a large circle passing through that point. So we are dealing with a Euclidean space, and then I define a right-handed coordinate system. So this is also called right-handed Cartesian coordinate system. In fact, it is called rectangular Cartesian coordinate system, in which we have chosen a right-handed system, or RCC. So rectangular means your coordinate axes are perpendicular to each other. Cartesian means scale for all three axes is same. Coordinate system, you understand, you are measuring distances along different directions. So we have got three coordinates, x, y, z, to represent any point in a Euclidean space. We can reach any point in a Euclidean space by three coordinates. So we are moving along three coordinate axes which are perpendicular to each other, and we can reach any point in space. And we also have to define an origin from which we will be making our measurements. Okay. Now also I did not tell you what is a left-handed coordinate system. So if this is my right-handed coordinate system, as I rotate my x-axis towards y-axis, so it's a right-hand counterclockwise movement, and the right-handed screw will come outwards towards you, like that direction I have shown. But if you assume, take a direction in the other way down. If you had a left-handed screw, it would have gone into the page. Then this would have been called a left-handed system. Now in a left-handed system, I cross j is equal to minus k. So this direction is k. We always define a cross product by a right-hand rule only. But had you chosen your coordinate system as x, y, z prime, then your screw I cross j has to be coming outward. But your positive z direction is inwards. So you have to put a minus sign. So your cross product rules change when you use a left-handed system. So always use a right-handed system, otherwise you may get into a problem of a sign. Now, what are the other properties of vectors? One thing I had to tell you is position vector. Position vector, take any point in space, connect it with the origin. So this is known as position vector of point A. Position vector of point A is basically represented by its coordinates. If you have got 2 points, you want to find the vector connecting them, point A and point B. So vector connecting them will be given by coordinates of point B minus coordinates of point A. So you will get ZB minus XB minus XA, comma YB minus YA, comma ZB minus Z. So this is a vector connecting point A and B. So you are going from point A to point B. And if you are representing vector BA, so you are going from B towards point A. So it's an opposite direction. This is minus of AB. Or you will say XA minus XB. So vectors have properties. One is vector addition is commutative. If you represent vector A plus vector B, this sum is equal to vector B plus vector A. How do you add two vectors? I got a vector A, I got a vector B. How do I add them? What I can do is, this is vector A. I move this vector B at the point from where vector A starts. You can shift a vector parallel to itself. Or what you can do, you can move it along its direction. So both of them are intersecting here. So that is what I prefer. So I have moved this vector to this point. So if I can represent so basically, instead of showing it here, I am showing it here. Okay. So what is the vector sum? You find the parallelogram. You just draw a parallelogram using these two vectors as the side. Then your output is represented by this diagonal. So this output C is diagonal of the parallelogram. So your output C is represented by the diagonal of the parallelogram formed by vectors A and B. Had you done like this, again you can do a summation using the parallelogram law of addition, or you can use triangle law of addition. triangle law of addition, you have got vector A. You put vector B where your vector A ends, and then you say this is your triangle law. C is equal to A plus B. So this C and this C, they will be parallel and their directions will be same and their magnitude will be same. You will get the same answer whether you get triangle law of addition or you use parallelogram law of addition. Same direction, same magnitude. But you will lose one thing. That I will tell you later on. You will lose line of action of the resultant code. So this is an important concept when we deal with forces. So I will tell you later on. So that is what is done here. You move the force, you move the vector along its line of action. This is known as line of action. Again here you moved it along the line of action. So these vectors are called sliding vectors. You are sliding the vector. Here, these vectors are known as free vectors. You have moved the vector parallel to itself. If this is allowed, you can do this. If this is allowed, you can do this. For forces, when force are vectors, we allow only sliding of the vector. In certain cases, we can allow translation of the vector parallel to itself. So in that situation, those vectors are called free vectors. So they will not lose their physical meaning. But forces, they will lose their physical meaning if you do like this. So, but they don't mind if they are slided in certain situations. If you want to do rigid body motion study of a set of forces acting on a body, we can slide the forces along the line of action. So this is something different, more complicated. I have just hinted about it. I will be dealing it with greater detail later on. So what I did just now was how to add two vectors. So adding two vectors, the best method is use law of parallelogram of forces. Second method is use triangle law of addition. Now how do you subtract two vectors? So that is not a very difficult job. Suppose you have got a vector A, you have got a vector B. Now you know what is minus B. You have to go other way around. So this is a minus B. Now summation of A and minus B will be subtraction of A minus B. So you draw a parallelogram. So this is your A minus B. While this is your A plus B. So this way you know how to add and subtract a vector, two vectors. If you have got more than two vectors, how will you do that? Now you have got a vector A, vector B, vector C. First pick first two vectors, any two vectors. Now you have to join extend them along their line of action. So now this becomes your vector A. This becomes your vector B. Now you make a parallelogram using these two vectors. This is your resultant vector A plus B. Now you have to add these two vectors A plus B and C. Now they are looking like parallel. Suppose they were not parallel. They are joining somewhere. So this is your A plus B. You bring the same magnitude here, and this is your vector C. So this is a vector A plus B plus C. So this is the way you will do by using parallelogram law of addition. Suppose you are using triangle law of addition. Then what you will do? You have got three vectors A, B, and C. First you write vector A. You draw vector A parallel to it. Then you draw vector B from where vector A ends. This is a vector B. Then you find your vector C. So A, B, and C. So closing side. Basically, you have moved from this position to this position. This is your summation of all three vectors. This is one crude example. Suppose you are having vectors lined up like this. Then this becomes your closing side of the polygon. This would have been A plus B plus C. Suppose your all vectors made a closed polygon. Then your net vector sum is 0. You go from here. So you are having A plus B plus C plus D. So you can see A plus B plus C. If you had sum these three vectors, you are getting minus D. Basically, you started from the beginning and you went to the final point where vector C is there. I hope vector addition is very clear to you. Now you can also do some trigonometry. Now how do you do? Suppose you take two vectors A and B. So you have vectors A and B. So there is an angle theta between them. How will you find the vector sum? So you can say these are coordinate axes x and y. Okay. I told you that vector sum will be given by the diagonal of this parallelogram. This is your a plus b. Another way of doing it is, this is your vector a. You can say it is so vector a can be represented by its components. I have taken x-axis along direction of vector a. It is in my hands how I choose my coordinate system. So x-axis is the direction of vector a. And now vector b is making an angle theta with x-axis, and vector b is in xy plane. I can make a plane from these two vectors a and b, and my z-axis is perpendicular to that plane. So what is my vector b? Now I can say it is
So mod b cos theta, comma mod b sin theta, and 0.
very good. Now what is summation of these two vectors? For vector sum, you have to only add the components. Just add the components. So what do you get?
So a plus b cos theta and y ke along b sin theta and z ke along 0.
So what is magnitude of a vector? How do you find magnitude of a vector? Suppose you
बस
have a
सबका
vector
स्क्वायर
v.
करके रूट कर सकते हैं.
Yeah. Suppose this is a vector v. So its magnitude is given by so we'll use that there.
तो इसका आएगा सर रूट ऑफ ए mod a स्क्वायर प्लस mod b स्क्वायर प्लस 2ab cos theta.
So you have already seen this formula. Okay. Suppose I call my vector A as A1, A2, A3. My vector B is B1, B2, B3. This is the way I generally like to do it. I write the components along three directions as this. Now what is my A plus B? Simply A1 plus B1, comma A2 plus B2, comma A3 plus B3. Now what is magnitude of vector A? One way to find is take the dot product of the vectors in itself. I'll tell you what is dot product. So this dot product is just given by a1 square plus a2 square plus a3. So this becomes magnitude of the vector square. Similarly, magnitude of vector b square is given by b1 square plus b2 square plus b3 square. So what is the dot product of vector a and b? It is defined as a1 b1 plus a2 b2 plus a3 b2. So this is dot product of two vectors a and b. Now I'll explain what is the meaning of dot product. Dot product is also called scalar product. So if you have got two vectors a and b, if you have got two vectors, you can always make them intersect if they are not parallel. We have to check this statement. There are skew lines which don't intersect. So suppose there are two vectors which are intersecting. If you extend them, if you translate them along their line of action, now you have made them join at this point. You can draw a perpendicular from one vector and to the other vector. This angle is theta. So this length of the projection here is b cos theta. So a dot b is given by magnitude of vector A multiplied by projection of vector B onto vector A. And this one thing to note in this is a scalar quantity. Suppose there is a force F which applies to a particle, and particle undergoes some displacement. So there is a displacement dr. So work done in moving the particle from this position 1 to 2. The work done by force F in moving the particle by displacement dr is dw f dot dr. The work is a scalar quantity. It is not a vector quantity. So if you want to go to position 3, you have to do an integration. So the work will be f dot dr You're integrating from 1 to 3. Suppose your f is constant during this entire displacement. Then what will you get? You can say f dot. F is a constant. You can take it out of the integral sign. Now this is what? What is the integral of dr? Just r.
Just just R.
So vector r, and you have to put the limits 1 and 3. So this way you see this dot product is a useful concept for finding the work. And we will use it quite frequently in this course. Okay. Now we have done dot product. Dot product is simply given by multiply the components of the vector, x component with x component of the other vector, and add it up. So this also can be written by the notation ai bi. If I is a repeating index, this is slightly advanced concept. It implies addition, and all three values have to be taken by the index. Index I. So basically it will be a1 b1 plus a2 b2 plus a3 b3. So I have written the entire expression on this side in short by this. This notation was introduced by Einstein. This is also known as Einstein's notation. So I have talked about dot product. Then there is something called vector transformation. I think about this I had talked in the last class, but I will briefly talk again. We have got certain vector. Let's call it vector A, or rather I like to call it vector V. Now I can represent it by another coordinate system. So vector V is independent of the coordinate system. But its representation depends on the coordinate system. So vector V, for example, I will say is v1i plus v2j plus v3k. Again, I can say vector V is v1 prime I prime plus v2 prime j prime plus v3 prime k prime. You see, I have got two different coordinate systems. Both are rectangular Cartesian coordinate system, but their axis orientation is different. So their components will also be different. How do you find components of a vector? How do you find components of a vector? You draw a perpendicular from the vector. You start the vector from the origin of the coordinate system. Now you draw a perpendicular onto one axis. So this vector v dot direction I is the component of vector v along x-axis. What is v dot I? V dot I is magnitude of the vector v, magnitude of vector I, and angle between these two vectors v and I, cos theta. So this is nothing but vector magnitude of vector v into cos theta. Magnitude of vector I is 1, it's a unit vector. So this will be called v1 component. Similarly, you can get component v2 as vector v dot j. Similarly, component v3 as vector v dot k. So you can get components of a vector like this. Basically, it is projection of the vector onto that axis. This gives the length of the projection along the coordinate directions. How do you find v1 prime? Now you have to draw a perpendicular onto axis which is x prime. This angle is 90 degrees. This angle is 90 degrees. So what is your v1 prime? Vector v dot vector I prime. You can make a table. I had probably done it last time. Take it as an x prime. So you have got two coordinate systems, x prime, y prime, z prime. Coordinate system x prime, y prime, z prime is obtained by rotating xy axis about z axis. So line x goes to x prime, line y goes to y prime axis. Basically, x axis goes to x prime axis, y axis goes to y prime axis, and z prime axis remain the same as they are rotating about the z axis. Now, what is the angle between x prime and x? Theta. You are assuming the rotation is by angle theta. So you can say, if you have to write theta vectorially, it will be theta k. You have done a counterclockwise rotation. Now, what is the cosine of the what is the angle between x prime and x axis? Theta. So cosine of that angle is cos theta. So this is known as L matrix. What is the angle between x prime and y? It is 90 minus theta. So this becomes cos of 90 minus theta equal to sine theta. Angle between x prime axis and z axis is 90 degrees. Because all these axes, x prime, x, y, y prime, they are lying in horizontal plane, and z prime are perpendicular to them. So angle between them is 90 degrees between x prime and z. So cos of 90 degrees is 0. Similarly, y prime axis and x axis. You see the angle is 90 plus theta. So you write cos of 90 plus theta equal to minus sine theta. Between y prime and y, it is cos theta. Again 0. So this way you get L matrix. And also I can define vectors I, j, k, and this is unit vector I prime, j prime, k prime. Can I write what is unit vector I prime? You will see that vector. How do I get vector I prime? Basically, I have to draw a perpendicular to the x-axis and a perpendicular to the y-axis. So this will be cos theta. This will be sin theta projections. So my vector I prime is
So I
cos theta I plus sin theta j. Since these vectors are perpendicular to z-axis, here that is not contributing. What is my j prime? You see here from here, cos theta I sin theta j. Here you expect minus sin theta I plus cos theta j. How you are doing? For j prime, you have to draw a perpendicular to the y-axis. You have to draw a perpendicular to the x-axis. So you see, will be y projection on the y-axis, cos theta, and this will give you projection on the x-axis. This has to be sin theta, and since the direction you are moving in minus x direction, you have got minus sin theta I. So this way you get the unit vectors along x prime, y prime, z prime axis, and k prime you see is equal to k. Now I have got vector v. I told you it is v1, v2, v3. This is in xyz system. I I have got it as v1 prime, v2 prime, v3 prime. This is in x prime, y prime, z prime system. Now I can say vector p is equal to v1i plus v2j plus v3k. How do I get v1 prime? I take a dot product with I prime direction. This will give me v1 prime. So what I have to do, v1 what is I dot I prime? I dot, this is nothing represented but I dot I prime. Angle between x and x prime is cos theta. So this is I dot I prime. What is this? J dot I prime. This is K dot I prime. What is this? J prime dot J. Similarly, this is J prime dot I. So I will again redraw the coordinate system here so that I don't have to go back and see. This is my I, J. This is my I prime, J prime. This is my theta. So I dot I prime, cos theta. J dot I prime. J dot I
Sin
prime
theta.
is sin theta. This is 0. So this is my I prime. This you can see also is I prime dot I. I can write it as L11 V1. V2 sin theta. This is nothing but L12. So I always use the first index for the prime axis. Prime axis is I. So if you represent I as 1, J as 2, K as 3, then I prime will become like 1 if it is of the prime system. You use the first index for the prime system. Other index for the, this I call it like a lab system. This is a rotated coordinate. So you want to find the rotated coordinates once you have the lab coordinates. This is a rotated system. Similarly, your J prime will be V1 I dot J prime plus V2 J dot J prime So what I am getting? I dot J prime cos 90 plus theta. Sorry. It is cos 90 plus theta means sin theta minus sin theta. J dot j prime.
Sir, cos theta.
So this is nothing but L 21 sin theta. Sorry. So I have written general expressions. In case k and k prime are not same. Similarly, you get v3 prime. What you can write without doing the entire exercise? L31 v1 plus L32 v2 plus L33. So you could have written another way. P prime P is equal to LPQ. You see, Q is a repeating index. So it means you have to write LP1 V1 plus LP2 V2 plus LP3 V3. P is not repeating here. P is not repeating here anywhere. So this is called a free index. So it has its own identity. You can replace Q, call it M. You could have written LPM, PM. Again, you would have got the same answer, same expansion. LP1 V1 plus LP2 V2 plus LP3 V3. So whatever is a repeating index is called a dummy index. So the only advantage of doing like this is you are writing in brief a long expression. So all this is thanks to Einstein's notation. Okay. So now what I have done is simply I have represented a vector in different coordinate systems. So vector components depend on the coordinate system, but not the vector. Vector stays the same. So these are known as transformation rules. For vectors. What is the transformation rule? V prime so prime is in prime coordinate system, non-prime is in the original lab system. So you could have also written it like this. So this is known as vector form. Or tensor form. This is component form. Basically, this you could have written V1 prime, V2 prime, V3 prime. These are the three components of this vector. This is your matrix. You see, in the matrix, your column index is the right index. It is same for first column, second for 2 for the second column, 3 for the third column. If we do this matrix multiplication, you will get the same equation. Suppose your P is 1, what you will get? V1 prime is equal to L1 cube VQ. This is nothing but L11 V1 plus L12 V2 plus L13 V3. Same thing here, L11 V1 plus L12 V2 plus L13 V3. Nothing great about what I have done. It is just putting the basic stuff you knew by trigonometry in matrix form. Suppose you want to write a computer program, it will be easier to do it. Later on, when we will go to stresses or tensors, this will be helpful. So I think I have done enough on vector representation. Basically, vector has to be represented by its components. Components depend on the coordinate system. As you change the coordinate system, the components will change, though vector is the same. I'll just take a small example to clarify a few things. Suppose I have a vector here. This vector has magnitude 5, and you can say it has components. Let's not talk about its magnitude. Suppose component in x direction is 1, component in y direction is 2. So this vector v is 1, 2, 0. This is the way I like to represent it. Now I take another coordinate system where this is my x prime direction. Now in this coordinate system, this vector is represented by, I'll say root 5, 0, 0. Now I have to mention which coordinate system I am talking about. So this is my x, y, z. Components don't have any meaning if you don't show the coordinate system also. We won't know in which direction we are going. What are x, y, z directions? And also one thing you will see, magnitude of a vector is invariant. What is the meaning of invariant? It does not change from coordinate system to coordinate system. This is something very important. Now what is the magnitude of this vector? Root 5. What is the magnitude of the upper vector? 1 square plus 2 square under root 5. Now how did I get this component? Now I know this angle is theta. What is cos of theta? 1 upon this diagonal. Diagonal is root 5. What is sine of theta? 2 upon root 5.
Root 5.
Okay. Now, how do I get here? What is L11? Because x prime and x, one is for x prime axis, this one, second one is for x axis. So this is cosine of this angle, 1 by root 5. What is L12? This and this. So this is nothing but sine of theta. Angle between x prime and y is 90 minus theta. So you get 2 by root 5. Okay. Since we are calculating v1 prime only, so I don't need others. L13 is 0. Now I am using this. My V1 prime is just dot product of this row with this column. V1, V2, V3 were 1, 2 and 0. So 1 by root 5 into 1, 2 by root 5 into 2, 0 into 0. So I get 5 by root 5, 4 by root 5 plus 1 by root 5 is 5 by root 5. This is nothing but 1 by root 5. Okay. So
Yes,
this is
sir.
what is coming here. I could directly write because I knew the magnitude of this vector is root 5 and that is independent of the coordinate system. And since this all this vector is in direction x prime, that is the way I have chosen my x prime axis. All other components are 0. So its magnitude will be the same as the component in x prime direction. So I could directly write root 5, 0, 0. So this information is important. You can escape doing all this hard work at certain times. Any problem?
No, sir.
One more thing we should know when we talk about vectors. How many degrees of freedom a vector has? How many degrees of freedom a vector has?
Sir, 3.
Very good. You are representing it by 3 components, and all of these components are arbitrary. You can choose any value, so it has got 3 degrees of freedom. Now, suppose I say how many direction cosines what is direction cosine?
Sir, this is also 3.
Suppose you have a vector. You have a vector v. So direction cosine means what does direction cosine mean? Basically, you have to find the unit vector. So this is a unit vector. So direction cosine means components of this unit vector. Okay. So what will be the components of this unit vector? Basically, what you are doing, you are finding v dot I. So if you this is v dot I, so this is magnitude of vector v into cos of theta. And now, if you are dividing it by magnitude of v, you are getting cos theta. So that is why it is called direction cosine. So it shows cosine of the angle between the vector and coordinate axis. You can always find the angle between these two lines. You have got any two lines in space, you can find the angle between them. Similarly, you can find the angle between vector v and axis y, vector v and axis z. So you see, you can call this angle as alpha, this angle as beta, and the angle between this as gamma. So direction cosine becomes cos alpha, cos beta, cos gamma. So this is a unit vector in the direction of vector v. Now, what is the property of a unit vector? Its magnitude is 1. So these direction cosines have only 2 degrees of freedom. So a vector is represented by magnitude and direction. Now since direction you are representing by the unit vector, so it has got 2 degrees of freedom, while magnitude has got 1 degree of freedom. So your degrees of freedom are again 3. Okay. So direction cosine is an important concept. So you should know that it shows that they are basically cosines of the angle formed by the vector between the vector and the different coordinate axes. So you know. Now how do you take 3 axes? Suppose you choose one axis. Look, your coordinate system orientation of axis is arbitrary. Only thing you have to ensure that they are perpendicular to each other. And they form a right-handed system. Okay. Newton's laws, I had told you earlier, invariant of origin or location and orientation of coordinate system. Newton's laws won't change wherever you put the observer, whatever is its orientation. So now, first axis, you have to choose the first axis. How many degrees of freedom it has? You are choosing basically first unit vector I. How many degrees of freedom it has? 2. You can put it anywhere in space, in any direction. You could have chosen, okay, suppose I define a lab system. Now I define another coordinate system. So this coordinate system okay. Now this is any line in space anywhere with any orientation. So just like any vector, you had 3 direction cosines and you had a restriction that magnitude is 1. So you said there are 2 independent direction cosines. Okay. So you can represent a vector in direction y Lm and n, and there is a restriction that their sum should be 1. Any problem? So this coordinate direction has some direction cosines with respect to some fixed system, and these Lm and n have only one restriction. So you have 2 degrees of freedom. Now I say you have to choose the second coordinate system, second axis. Now what is the restriction? You are choosing another line in space. How many degrees of freedom this line has? This line can be any line in the plane normal to x-axis. You can choose any line in the plane normal to x-axis. So you choose any vector here. It has got coordinate, it has direction cosines L prime. What is the restriction? Number 1, its magnitude is 1. What is the other restriction? Dot product between these two vectors should be 0. You know perpendicular vectors, their dot product is 0. So you have got 2 restrictions on these 3 values. So your degree of freedom becomes 1. So second line, second axis you are choosing, it has got degree of freedom as 1. So you got x-axis, you got y-axis. Suppose this is your y-axis. What will be your z-axis? You will find from the cross product. The third axis, cross product or vector product. Same name. Both things mean same. This is direction I, this is direction j. So basically once you know I and j, now k is immediately fixed. It is given by right hand rule. Vector k is given by right hand rule. It is perpendicular to the plane formed by x and y axis, and also it should follow the right hand rule. As you take x axis toward y axis, z axis should point towards the way, in the direction in which a right handed screw will translate. Okay. So I have told you about vectors and coordinate systems. So when you used to analyze motion of a particle, I had told you what is a particle. It occupies 0 volume. So it is a kind of a mathematical concept. It is represented by a geometrical point. Now, you show a coordinate system for seeing this particle. You measure the location with respect to this coordinate system. You move in x direction by distance x, again in y direction by distance y, and z direction. So you can reach a point x, y, z by moving along three perpendicular directions equal to the coordinates. Now if you have a rigid body, how you can analyze its motion? One thing you can do is identify its center of mass. You can put your coordinate system at the center of mass. Now you will see, as this coordinate system, as this body rotates, coordinate system also rotates. Position of every other particle is same. Suppose this is my coordinate system and this is my rigid body. Now position of every other particle is defined with respect to this coordinate system. Now this body has rotated like this, suppose. Now I change the outline of the body. Now the coordinate system is, whatever was this coordinate system, the whole thing has rotated. Now only thing is coordinate system has rotated. So this point which was here, it was at angle theta. Same angle theta is there. So with respect to this rotated system, position of the particles is same. Now you are viewing with respect to this observer which has rotated. Again they have same coordinates. Only thing is coordinate system has rotated. With respect to this rotated system, all particles have same coordinates. So if you want to analyze the motion of this body, you have to just find, number one, origin, number two, orientation of the axis. Now these x, y, z axes have different orientations. You see, every coordinate system can be defined by 3 degrees of freedom for its orientation of the axis. And other 3 degrees of freedom are of the origin. This also has got 3 degrees of freedom. This orientation also has got 3 degrees of freedom. So overall a rigid body has got 6 degrees of freedom. So we'll discuss it again later on. The class is over for today.